You're my only honors class. So, all right.
This is your only honors? This is your only honors class?
So, when we have this polynomial function, this one specifically is cubic, we are going to solve for the x values, or my solutions to this function, by manipulating what we have. So first of all, it's not a function yet, right? Why is it not a function? Say that again? I see an x. What do you not see? Y. There's no output, right? So I have an input, no output. So what we're going to do to manipulate this function and be able to graph it is we're going to say if this 0 was actually a y value, then what would our equation look like? And I don't want to put an equal. And I'm going to write my y value on the left because you're always used to seeing your y first and then the rest of your equation, right? So how would I write this if I'm plugging in y for that 0 right there? What's my sign going to be? Less than. So this is going to be y is less than x minus 1 times x minus 2 times x minus 4. That tells me a couple different things. First of all, it tells me whether my boundary line is going to be dashed or solid. Is it going to be dashed or is it going to be solid? Dashed. And it tells me where we're going to shade. Are we going to shade above or below? Below. Why below? Less than. That's a less than symbol. Some of you are, the hardest part for you is just remembering which one of the symbols is less than or greater than. So, less than points to the left. Or like, just if you were to look at your x-axis, and if I were to point an arrow to the left, that's all my numbers that are less. And if I were to point an arrow to the right, that's all my numbers that are more. All right, so we're going to graph the function with a dashed boundary line. What x-intercepts am I going to go through over here? 1, 2, and 4. I'm going to space these out so you can see them. So I'm going to space all of these out by 2. So this is going to be 1, 2, 3, and 4. Do I want open points or closed points? Why open? Yeah, so this also means open points because it's less, I don't have an equal to part. Okay, so where did I get the 1, 2, and 4 from? Setting each of your factors equal to 0. So then we solve and get x equals 1, x equals 2, and x equals 4. Now in order to graph my polynomial, this one you could determine the y-intercept from. What's my y-intercept in this case? My y-intercept is not 0 because my x-intercept isn't 0. But I could plug in 0 for x if that's what you're saying. So plug in 0 for x, you get -1. 0 minus 2 is -2. 0 minus 4 is negative 4. What's your y-intercept? Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That's on here, so I'm going to go ahead and plot it. Sorry, that would be an open point also. But I'm not looking for the y-intercept necessarily if you can't graph it on this problem. What I'm looking for is the solutions for x. So we're trying to figure out what numbers on this number line right here, where are my solutions? Are they in between 1 and 2? Are they on the outside of those numbers? But they're going to be along your x-axis. So the only way we determine that is by doing our boundary line and our shading. So that y-intercept does help us because it helps us to graph our function. What's the degree of this function? 3. So that means my end behavior is going to be opposite because that's an odd function. So that means opposite end behavior. What's my leading coefficient? 1. We do 1 times 1 times 1. That gives us 1, which is positive. Okay, so which end behavior do I find first? The right side, and that matches the leading coefficient, so positive. And if my two end behaviors are opposite, then the left is negative. So you could have probably figured that out by drawing this in, but do I have any bounces? No, these are all to the first power, so no bounces. We're going to pass through every point. And where are we going to shade? Above. I'm going to show my highlighting as my shaded portion. This highlighted portion on this problem is not the solution everywhere because we're not finding points. Oh, I'm sorry, you're right, below. Thank you. Shade below. Thank you for calling it out before I did it. Shade below. And the shaded portion is not all of my solutions. It's just going to help me find my solutions for my x values. So we're shading below. And your x values are your solutions. So you look at your x-axis. What numbers are solutions in this highlighted portion? Anything between 1 and 2. So we're going to write out our solutions. Does it tell us whether they're to do interval notation or inequality notation? Interval. Okay, so that means you have to do interval notation. I am going to write out both just so that we practice both notations. But let's start with interval because that would be your answer. How do I show all of the numbers between 1 and 2 are solutions in interval notation? Parentheses, 1, comma, 2, parentheses. Why am I using parentheses here? Good, they're open points. It's a dashed line. You can say it's less than, it's not equal to. All of those are correct answers because they all come from the same information. Do I have more solutions on the x-axis? Yes, this x-axis is going to keep going. And this function keeps going above forever, so I can highlight all of these x values to the left because technically all of this area are solutions, right? So I pick up at 4, and where do I go till? Infinity. So that is your answer for your solutions. If I were to write that in interval notation, that is 1 is less than x, which is less than 2, or what's my other inequality? X is greater than 4. Okay, you don't have to do inequality notation. It's just good practice. questions about that problem? All right, so tonight I'm going to go ahead and stop this.